exponential rules for dividing monomials and the exponential rules when I have a zero exponent. Let's just review what we did yesterday. In the first example of the do now, I have 2x and that entire quantity is cubed. Again, everything in that parenthesis is the base. 2 is to the first power, x is to the first power, so it is considered a power to a power. My final answer would be 2 cubed x cubed. Again, if we don't remember what to do, we can always expand it and write that entire base out of 2x times 2x times 2x to realize that it is going to be 2 cubed x cubed as my final answer. If I take a look at 2a squared divided by b to the fourth, and that entire base is now cubed, the same rule applies. I'm going to put a little 1 as the exponent for the 2, and I am going to make sure when I do apply the power to a power rule, in my numerator, 1 times 3 is 3, 2 times 3 is 6, and I also have to apply that same rule to whatever I have in my denominator. So 4 times 3 would give me the 12. And this would be my entire answer. Again, please be mindful. I am taking this entire base, which in this case happens to be a fraction, and I am multiplying it by itself 3 times. If you are not sure what to do, expand it out. And then b to the fourth times b to the fourth times b to the fourth would give me that b to the 12th. In this situation, x squared divided by 3 squared, that entire base is now squared. My final answer, I am applying the power to a power rule, x to the fourth divided by 3 to the fourth. And that is a review from yesterday. Now, if I try to figure out what we did today, I now have a division, 3 to the 7th divided by 3 to the 5th. I had asked you to write it out using expanded form, so I have 3 times 3 times 3 times 3 times 3 times 3 times 3, and at the bottom I have 3 multiplied by itself 5 times. I am allowed to simplify. Remember, when I asked you to simplify today, we don't just cross them out. They simplify to 1. So 3 in the numerator simplifies with 3 in the denominator. And I can do this for every pair that I find in that numerator and that denominator. And you have to show that it simplifies to 1. What I am left with is 2 3's in the numerator, or 3 squared. So doing it this way, I am now able to hypothesize my rule. My rule here, when bases are alike, you're going to keep the base and subtract the exponent. So for example, x to the n power divided by x to the n power, keep the base of x is equivalent to x to the m minus n power. And this is the division rule that we are going to use with our exponents. When I take a look at this example we did in class, I have 3/5 raised to the 8th power divided by 3/5 raised to the 6th power. 3/5 is a like base. Keep my base. Now let us subtract the exponents. 8 minus 6 would give me 2. In this case, I have to show the parentheses. Otherwise, it just looks like that numerator is squared only. You have to put that entire base inside the parentheses. When I look at example number 4, 4 to the 5th divided by 4 squared. My base of 4 is the same. Keep the base, subtract the exponents. 5 minus 2 would give me 4 cubed. And that would be my final answer for that one. Now I get into the little bit more sophisticated type look. Again, please remember, 3x to the 8th is really over 1. So I like to clean this guy up a little bit first. So I am going to do 5 times 3x to the 8th in my numerator, and x cubed times 1 is x cubed in my denominator. It's cleaned up a little bit, makes it a little bit easier to see what is going on. Now let's take a look at that numerator. 5 times 3 is 15, x to the 8th divided by x cubed. I'm not done. I'm not in simplest form. 15, and keep the base of x. Subtract your exponents. 8 minus 3 is 5, and that would be my final answer for that one. Let's try another one. Number 2. Again, the negative 4x to the 6th is really over 1. So to clean it up, I would write it as 5 times negative 4 x to the 6th divided by x cubed. X cubed times 1 is x cubed. When I go to evaluate the numerator, 5 times negative 4, negative 20 x to the 6th divided by x cubed. That is not my final answer. I am not in simplest form. I see a common base of x to the 6th divided by x cubed. Subtract the exponent. 6 minus 3 is 3. And that would be my final answer. Again, we did these in class. It's just a refresher to make sure we are okay. I think we're okay on that one. Okay, let us now go to, sorry, I'm skipping around a little bit. Let us now go to 3 to the 0 power. What does that mean? Okay, doing the math, 10 squared is equivalent to 100. 100 divided by 100 is equivalent to 1. Using the laws of exponents, my base of 10 is the same. Keep the base, subtract the exponents. 2 minus 2. This is equivalent to 10 to the 0 power. Let me now do this with another example. 5 cubed. Using my math, 5 times 5 times 5 is 125. 125 divided by 125 is equal to 1. Using my laws of exponents, the base of 5 is the same. Subtract my exponents. 3 minus 3, it is equal to 0. I get 5 to the 0 power. So what this is telling me is 0 exponent, any non-zero number raised to the 0 power is always going to be equal to 1. Now I would like to go over my rules. This is a summary of my rules. When I take a look at the first one, x to the m times x to the n, keep the base and add your exponents. X to the m plus n. In the next example, x to the m raised to the n power, that is called power to a power. My rule here is you keep the base and you multiply the exponent. So it would be x to the m times n. Again, I have a power to a power now with an xy. I'm going to put a 1 here, x to the first power, y to the first. And when I apply the power to the power rule, I would have x to the n, y to the n. Division, x to the m divided by x to the n. You are going to keep the like base and subtract your exponents. And I would end up with x to the m minus n power. And lastly, if I have a fraction that is raised to a power, you have to make sure you show x to the n in the numerator and y to the n in the denominator. And this should summarize everything that we have done over the last 2 days.